Okay, so there are 44 carbons here. I just was messing up with my counting and I missed those two the first time. So as you can see, that's a easy mistake to make. But yeah, there's 44 there. You can double check my work if you pause the video. But yeah, so then moving on to the next problem on this page. So we have this really, really intimidating structure. It's like, what are we even supposed to look at here? Because there's so much. So you have to look at just the entire thing to figure out whether it's an acid or a base. But you see here that there's going to be an acid-base reaction, and hydroxyl is a known base. So that's pretty obvious that it's going to be a base, but we can double check by making sure that the other structure is an acid. And if we look, right here on the end is a carboxylic acid. So that has acid in the name. So we know that that's going to be an acid. And so for acid-base reactions, the hydrogen is donated by the acid to the base. So it says to save drawing time, circle and label an R group on the starting structure. So what I'm going to do is we have that red circle that is the carboxylic acid right here. And so the rest of the structure is irrelevant for this question. So we're going to call all of this our R group, even this carbon right here. Actually, maybe not that carbon. That might make it a little bit... No, that's okay. We can include that one. So we're going to call this entire thing R, including this carbon. That's the very end of it. And so when we copy that below, it's an R, and then that's attached to the OHO, but this oxygen here, with its lone pair, is going and grabbing this hydrogen, and then the electrons between the oxygen and the hydrogen are going to the oxygen, and so we're actually not going to have this hydrogen right here. It's just going to be an oxygen with a negative, because it's getting those two electrons. So that means that there will be 6 electrons there, which gives it a negative formal charge. But you don't need to draw those electrons. That's just to double check. And then we're left with water. Oh wait. Okay, so it's saying the water's right here, and it's saying to show the resonance stabilized anion product. So it's saying to show the other version of the resonance. And so we can do that by moving the electrons that are in the pi bond onto that oxygen, and then moving this lone pair here to form a pi bond. So then that's going to be R O negative and O. So yeah, that's what stabilizes the resonance there. So that's the first page of midterm 1.